Hello everyone, and welcome to today's webcast, Privileged Domain Account Protection, How to Limit Credentials Exposure. My name is Trevor, and I will be moderating this webcast. Today's featured speaker is Mike Pilkington, Senior Incident Responder. Before I turn things over to him, the Q&A portion will take place at the end of the webcast. Feel free to submit your questions at any point by using the questions window. Right now, I'd like to turn things over to Mike.
Okay, thanks, Trevor. And welcome, everyone. It's great to be with you today, and I'm happy to be talking about a subject that's not only very interesting to me, but also, I think, very important as well. So a little bit about this presentation. It's grown over time and grown out of really several years of researching how our Windows credentials are exposed and what we can do to avoid that exposure. So I first started thinking about this and kind of researching it when I switched into an incident response role in 2009. And when I first started, I was logging into compromised hosts to triage them, to do some initial analysis, but I was always, really paranoid about what, sensitive credentials I was leaving behind. And of course, if I had any doubt, I would just quickly change my password to be on the safe side. But not knowing exactly how my credentials were exposed, it really kind of gnawed at me. So I just set off on this journey to kind of dig into this topic. So the good news is, and unfortunately there is some good news, is that there actually is a method, a set of steps we can take to protect our privileged domain accounts. And in fact, our built-for-purpose privileged domain accounts are actually better suited for protection than our standard user accounts that we just use for our normal day-to-day use, and we'll see why that is here shortly. A little bit about me before I kick it off. I'm currently an incident responder for a large oil and gas company in Houston, and I've been with this company for 16 years. I've done a lot of different things that I think has helped, and one of the things I like about forensics and incident response is that typically the more background you have in IT, the better. And I've had the ability to do a number of different things, from software testing to systems administration and later network administration and firewall and IDS management. But since around 2008, 2009, I got into the computer forensics group in our company, doing initially kind of HR type investigations, and then since 2009 been really dedicated to incident response. I'm also a SANS certified instructor. I teach two of the forensics classes, Forensics 408, Windows In-Depth, and also Forensics 508, Advanced Forensic Analysis and Incident Response. So as you see there on our slide, we have a Forensics 408 VLive session coming up soon, and those are a lot of fun and quite flexible, allowing you to log in from home without having to worry about being away from your family for a week at a time. So definitely check that out if you're interested. Okay, so let's get into it, and we've got a lot of material to cover, and looking forward to covering it with you. And like Trevor said, we'll have time for, hopefully, some time for questions at the end. I also will have my contact information at the end, so you can email me if we don't have a chance to get to your question. So I mentioned why I got interested in this topic. As an incident responder with a highly privileged account, I was concerned about, exposing credentials on those compromised hosts I was logging into. But it's not just incident responders that have to log in untrusted hosts. There's our server admins who are logging into various types of servers that may be at risk. There's also the functional accounts that are used to scan your environment. These, in many enterprises, there could be a number of these highly privileged accounts that can log into most, if not all, of your systems for things like vulnerability scanning and patch management and running backups and more. So of course these accounts could be at risk too, and so we need to take the steps to ensure that they are not stolen by attackers. We want to basically do everything we can to protect these hosts, and we'll talk about how we might be able to do that. Because these types of credentials are the keys to the kingdom. They are definitely what attackers would love to get their hands on. So how do we go about securing these accounts? As I mentioned a moment ago, we've got actually some good news here. We can really do a pretty effective job in many cases. And we'll talk about where there might be caveats. But in many cases, we actually can do this with these built-for-purpose domain accounts that have highly privileged access. Now, I want to kind of highlight that first bullet there, that this is specifically recommendations here for remote authentication to trusted hosts from a trusted host. So we're assuming that the system that you're launching your IR investigation from, or the systems that's running your scanning tools across the environment, that those hosts are locked down and properly secured. But when we reach out to untrusted hosts, we actually can do a pretty effective job of securing our credentials by doing these three things listed at the bottom. We need to avoid interactive logons, which we'll cover first. We need to protect the delegate level access token, which we'll spend some time on. And finally, enforce Kerberos network authentication. And we'll talk about that in detail as well. All right, so first we'll talk about avoiding interactive logons. Now, I'll have a little bit more kind of rigorous definition of what an interactive logon is here in just a few minutes, but for now, just think of interactive logons as essentially you've got a Windows desktop in front of you. If you log in and you've got a desktop, whether it was virtually over the network with remote desktop, or you're sitting in front of the machine, that's a remote desktop. And the thing about an interactive logon, when you think about it, and you've got that desktop in front of you, once you have that, you can pretty much go anywhere in your environment without having to re-enter that password. And that single sign-on functionality is enabled by all the credentials that are loaded in memory with an interactive logon. And there's even a set of credentials that persist on the disk, which we'll talk about here in a second, the cache credentials. So a lot of credentials get stored both in memory and even on disk when an interactive logon occurs. Okay, so what I want to do is actually talk about, first off, password hashes and how they're created and where they're used. And this is a pretty busy slide, so let me just kind of hit the main points here, and then in the following slides, I've got some pictures and screenshots to kind of help hopefully drive home the points here. So the purpose of the password hash is to store a representation of the password rather than the actual clear text password itself. And that should be for obvious reasons that you don't want to store the clear text password. Now, for domain accounts, there are actually two kind of categories or two types of hashes that are created for domain accounts. One is used for network authentication, and that's the NT hash as well as the older LM hash. And then there's another hash that's created for local logins when the domain controller is unavailable, and that's the cache credential. So let's dive into each of these types, and we'll start out with actually the NT hash. So I'm going to try to illustrate this in a few slides here, and not only like how the hash is created, but also how it's used and where it can be exposed. So the first type here is the NT hash, and again, there's potentially the LM hash for legacy systems, but I'm just going to assume, that you've got all your systems patched. At this point, the LM hash should not be used any further. Fortunately, the NT hash is stronger than the older LM hash, but it is still vulnerable in certain ways. But let's take a look first at what it is that and how we create this particular hash. So when my user here is Mike, so I'm logging into my workstation, and the first thing that happens, I type in my password. Well, for the purposes of being able to perform network authentication later, Windows is actually creating that NT hash and storing it in memory. All right, so I've got a super secure password here, password1, and it turns out for the NT hash, it's simply creating the NT hash by running the MD4, the Message Digest 4 hashing algorithm. So the password1, the Unicode version of password1 is actually sent through the NT hash algorithm, MD4 hash algorithm, and outspits that hash value. Now that hash value is loaded into memory, and stored with my account so that the next time I need to do a remote authentication using the NTLM challenge response protocol, and we'll be talking about that before too long, we actually authenticate with this hash rather than the actual password. So that's why we need to keep that. Basically, it's there for single sign-on purposes. Now, the good thing about a hashing algorithm is that it's essentially a one-way function. You can, well, let's say, okay, so I forgot about this guy. This is my little attacker. We're a week away from St. Patty's Day, so I thought it'd be fun to have a little leprechaun as my attacker. So let's say an attacker's got control of my system, and he's able to steal my password hash. The nice thing about the hashing algorithm is that you can't take that hash and run it back through the hashing algorithm to reverse out the password. That's actually not going to work, and that's a good thing. But as we'll see in the Windows world, there's actually some ways to get around this, and so this is kind of what we have to be aware of as well. So there's really two possibilities or problems, and one is that essentially the hashes can be used to pre-compute all the possible ways that the password created that hash, and then the hash itself can be used to authenticate directly. Okay, so let's talk about those here. Really, the main problem with this idea of pre-computing the password hashes is that the NT hash doesn't use a salt. In other words, it doesn't use anything unique. So when the password is created, or when the password hash is created, it's just the password itself that runs through and fed into the hashing algorithm, nothing else. Ideally, you'd have something unique in there with each user's password so that my password, password 1, and say John's password, password 1, would not be the exact same. All right, but with an NT hash used directly for authentication to remote systems, that's in fact what happens. So this sets up what's called a rainbow table attack, where attackers can essentially take the time and effort to pre-compute a whole bunch of passwords and their corresponding password hashes, and you get this massive database, and that is essentially a rainbow table. And then our little leprechaun attacker there can steal a user's password hash, and if they have a rainbow table that's got the corresponding password that would have created that hash, well, now they have the password. So the NT hash is vulnerable to a rainbow table attack simply because there's nothing unique mixed in. My password of password 1 and John's password of password 1 that I had on the previous slide, they had the exact same password hash, that password hash at the top. Okay, so that's one problem. The thing about it is even if that weren't a problem, and let's say one mitigation step I should point out, we'll go back one slide. One mitigation technique I should mention about this is that the NT hashing algorithm is unique enough, and there's enough possible variations of it that once a password gets to a certain length, it kind of becomes, I would say, like not feasible to create a rainbow table that's going to crack all of these possible passwords. So that's where you want to start getting into the longer, stronger passwords, into the 10, 12, 14 character passwords, if not higher. Really be thinking about it as far as pass phrases. Because at that point, it's just not feasible to create these rainbow tables that could have, this huge number of passwords and password hashes. Now, that said, even if you've got a nice, long, strong password of 20, 25 characters, whatever the case may be, there is another problem with the password hash, and that is that the fact that all that's really needed to remotely authenticate to a Windows system, in most cases, is the hash itself. And that's because the hash, not the password, but the hash itself, is used to answer the challenge in the NTLM challenge response. So here's how this goes. I've got Mike with his password hash loaded in memory. He's going to log into this remote server, simply ask the remote server, can I log in? sure, you can log in. Just answer this challenge that I've issued based on your password hash. And so sure enough, yeah, he's going to pass along the answer based on his password hash. And basically, that in a nutshell is all that's required. No password needed, but the hash is all that's needed to remotely authenticate as that user. And that's essentially what is pass the hash. So at the bottom there, just have kind of a screenshot of showing that in action, where we've got a pass the hash tool that's able to run WMI queries against remote system. In this case, using just the hashes for user Mike, I was able to remotely connect to a system and query, in this case, just the kind of the specifics about the computer and the OS. But all that was necessary was the user and the hash that can be stolen right out of memory, because those hashes are loaded in memory. Okay, so last but not least, there is the cached credential hash. So, as I mentioned there, the NT hash is used specifically for network authentication, and that's loaded in memory as soon as you log into the system. But there's also this type of hash that's used for local authentication when the domain controller is unavailable. This is the cached credential hash. So when you're in a Starbucks or on an airplane, you can still log into your domain account. It's cached credential hash is there to provide that verification of your password right there on the system, even if the domain controller is not there. So the way that this is calculated is a little complicated, but actually uses the NT hash somewhat. So we start out by actually having the user, when they log in, their password is actually converted to the NT password hash, which they have to have anyway. This is the NT password hash that's stored in memory. But then that is actually run through the hashing algorithm again, and also with the username. So we add in that hash plus the username, and this becomes a salt. This becomes something that's unique for each user that's added into the hashing algorithm. All right, and so the nice thing about this is that means that although the cache credential is still certainly sensitive, the nice thing about it is it can't be stolen and used directly for a rainbow table attack, at least not in most cases, because each of us are going to have a different hash even if we have the same password, because we have different usernames. Now, I will mention, though, that that's not to say that an attacker or attack group might not take the time to create a rainbow table for very common account names, such as administrator. So, a little point here, a little heads up is it might be best to not use the built-in administrator account, for the domain in your environment, to disable that, and other potentially very common names. But administrator, that built-in domain admin, is definitely something you'd want to probably disable and not use directly for this particular reason. And the reason for that is because these hashes are stored on disk. That is the whole point of this, is that if in case the domain controller is not there, you can log in. What's crazy to me is that so by default, there are 10 domain users' cache credentials that are stored on a workstation, but for servers it's 25. So 25 of the previous users that have logged in to that system, interactively logged in, I should really make sure to put that. So 25 of the previous interactively logged on users, their cache credentials are stored on disk. So an attacker can steal these hashes and then attempt to brute force them, because basically we have the algorithm right there. That's exactly what it takes to calculate this. But for a long, strong password, it's probably not likely that they're going to crack it. And also, fortunately, this cache credential that they get off disk, this is not the direct NT hash that can be used in authentication. But still, something to be aware of, and yet another reason to avoid interactive logons. Okay, so another thing that's created with interactive logons are these Kerberos ticket granting tickets, which actually act very similarly to, in some ways, to the NT hash. They're used also for remote authentication, but with Kerberos instead of NTLM. So I'll definitely cover Kerberos in more detail here shortly, but for now, just recognize that in a Kerberos world, essentially what we need to connect to a remote system is a service ticket, and the way that we get that service ticket is by negotiating with the domain controller and getting actually a ticket granting ticket. So every time I need to log into another system, I pass the domain controller a ticket granting ticket, and they, if assuming I have access, will provide me a service ticket that is uniquely addressable and provided specifically for that remote system I need to connect to. So boils down to the ticket granting ticket is very much like a password hash, and if an attacker steals the ticket granting ticket, they can then just do that same negotiation with the domain controller and request a service ticket to the system they want to log into. And so this has been coined instead of pass the hash, pass the ticket, because it works almost the same way. So I'm sure a number of you recognize that not only are hashes there, not only are the tickets there, but even the passwords themselves. And of course, storing a password, not a great idea. That's why they started out with the hashes. But for whatever reason, Windows has chosen to do this in a few instances. So basically, a couple of years ago, there's a brilliant researcher in France named Benjamin Delpy who really discovered this, and basically discovered that the user's password is actually stored in memory. And it was stored and cached in memory and kept in an encrypted form, but once he realized what was going on, he was able to decrypt it with a standard Windows API function. And so he created a tool, Mimikat, which is shown here in the screenshot, and this tool originally was able to parse out the password from multiple locations, but as of May of last year, a patch came out, this KB 287-1997, came out that actually created and improved security in quite a few ways. So I'm going to hit on that throughout the presentation, some of the things that have been implemented with this patch that brought the older operating systems like 7 and 8 almost up to the level of Windows 8.1 and Server 2012 R2. There are some caveats to that for sure, but we'll hit on some of those as we go. But by default, you can see here that even with this patch applied, we still have one security service provider. That's what these are called here. There's the TS package, and then WDigest is what I'm showing here. There's essentially one security service provider that still has the password stored in memory and can be dumped with this tool. And that's WDigest. WDigest is an extension to HTTP authentication. It basically improves upon HTTP basic authentication. And since instead of sending credentials in the clear, it does encrypt them, and so that's an improvement. But Windows needs to store your password to do that seamlessly, basically to do it with single sign-on capabilities. So when this patch came out, it actually removed some of the other security providers, or removed the password from some of the security providers, but it actually did keep this one by default because Windows or Microsoft was concerned that there were too many users that still would be using this in production environment, and that by removing it, they would break a lot of environments. So what I want to do is I'm going to break out of, whoops, let's see if I can do this right, break out of this and show you an article, and I've got this in references at the back of this presentation, so you'll have quite a few links. This is one of them that's a really nice overview of this pretty significant patch that came out last year, June of last year, May-June timeframe of last year. And what you can see at the top is, like I mentioned, basically it tried to bring some of the older but still current operating systems up to speed with the latest. So the latest being Windows 8.1 and Server 2012. Now, they couldn't do it in every case. There's some caveats which I'll mention here shortly. But one of the things they did, and towards the bottom, it talks about, let's see if I can find it. removing those clear text credentials from LSAS, from these security service providers. But they specifically said that WDigest is still stored because Microsoft didn't want to, take the chance it was going to break existing customers. Fortunately, and the reason I point this out to you is that it does have recommendations here in the link below for how to query your logs and looking for evidence of this digest authentication. So if you query your logs for a certain amount of time and don't see any evidence of it, then you can actually go ahead and provide or apply this next KB patch and remove that from memory as well. So just below here, these are the specifics of what you would look for in the domain controller logs. All right, so that's what I've patched versions 7 and 8. Just for comparison's sake, worth showing you that Windows 8.1 and 2012 R2 by default do not have the password stored in memory. So that's a good advance. Yay, Microsoft. All right, so we've just seen basically a ton of reasons to avoid interactive logons. All those things came about and stored because of interactive logons. The password themselves, the password hashes, the tickets. So plenty of reasons to avoid interactive logons. Specifically, and I'll say this, specifically to untrusted hosts. Okay, so you may still need to do interactive logons with your privileged accounts, but you want to make sure those are on hosts that you trust and know are secure. So what exactly makes an interactive logon? As I mentioned earlier, the simplest form of an interactive logon is one where you're presented with a desktop. And this can be done at the console, where you're sitting physically in front of the system, or remotely with tools like a remote desktop, even Citrix and VNC and remote admin and Dameware. All of these tools that allow you to essentially reach across the network and get an interactive desktop environment. There are other ways of doing it that are maybe a little more subtle. For example, even the run as command, where you launch a program as a different user, that actually is performing an interactive logon with that user account. And there's also programmatic ways to kind of under the hood create an interactive logon, and there's reasons to do that. But if it does that, you need to be aware of it. And one example that I mentioned there is psexec -u. That actually does create an interactive logon. So I know a lot of people, probably both administrators and certainly incident responders, are used to using psexec. It is a very versatile tool, but can be dangerous. In fact, it's very dangerous with the -u option specifically. So what is the safe way to do it? The safe way to do it is with a network logon. And a network logon, on the other hand, is one that essentially typically is over, file and print type CIF style connections, or MSRPC type connections with WMI, WMIC, and even PowerShell remoting, which is over the WSMAN protocol. PowerShell remoting is a really neat feature. I won't really delve into it too much in this case, but in one iteration of it, and one way of invoking it is you basically get like a SSH style connection to a remote system. And that, even though you're basically interactively working with that remote system, you're kind of on the console, or at least on a shell of that remote system, that's still just a network logon, which is really nice. So this one should get your attention. There's a lot of orange there. Orange is caution. Watch out for orange. Green is good, so we'll just kind of start at the top there. That event, well, let me back up a little bit and say basically that anytime a user logs on to a system, this event ID 4624 is going to be created. And one of the pieces of information that's recorded there is the logon type. And the logon type is important for us understanding, how they logged on, and basically kind of profiling the exposure of the box as far as these credentials are concerned. So the first one to notice there, we'll just highlight the green. The green is good. That's the network connection. We talked about that being kind of CIFS or MSRPC or WSMAN type connections. Those create network logons, and the way we can tell for sure is that looking at the event ID 4624, the logon event for your user account of interest, if the logon type that's specified is type 3, then that's a network logon, and all of those credentials don't get exposed on that system. On the other hand, basically any of these other ones I would consider, again, cautious. Be cautious. Essentially all the others imply that password and credentials were stored there locally, either through the user typing them in, which is more along the lines of the interactive, like type 2 at the top, that's your standard logging in at the desktop, or going down to type 10 at the bottom, which was remote interactive, and that's more of the remote desktop style connection. But even like type 4, a batch logon, is basically like a task logon. Well, that implies that that user's credentials are stored on that system to actually invoke that task, that batch process. So let's look at a few examples of this, just focusing here on two of the ones that are of concern. Type 2, this is an example of a type 2 logon, and so this was somebody logging on at the console of this workstation. Here is a type 10 logon that was remote interactive, so this is more of an RDP, remote desktop type connection. And then finally, this is what we want to look for our privileged accounts, is that they're specifically and only doing a logon type 3. So that basically covers all of the things that are exposed with an interactive logon. Maybe actually not even all. We're going to talk about what happens too with delegate level tokens here in a moment. But what we're seeing is many significant pieces of credential information that are stored on the system when an interactive logon occurs. So what do we need to do to safeguard our privileged accounts? We need to take the time and effort to make sure that those privileged accounts are only performing that network logon type 3. What I would recommend is essentially, for any systems that these tools interact with, or that your processes, from an IR perspective maybe, that your processes interact with, go ahead and kind of validate what type of logons have occurred when that process runs or when that tool runs against that machine. And what I mentioned there at the bottom is make sure to be thorough, because I have seen tools, including some vulnerability scanners, that will initially create a network logon to do some part of the work, but then actually create an interactive logon as well at a later time. So you want to make sure you're kind of combing through those logs, looking specifically for those logon event IDs, the 4624, through the course of that tool or process's interaction with the system. So I make it sound like this is pretty easy to just we'll just do interactive or network logons with our privileged accounts. And I think for a lot of cases, at least the use cases I've talked about, where we've got systems that are reaching out for doing patch management or kicking off a backup or doing some IR processes, I think that in many of those cases it actually is quite simple and probably already in most cases is doing that. You might just need to take some additional steps to make sure that you don't have a rogue tool out there that's doing an interactive logon when it doesn't need to. But that said, there certainly are cases where a privileged account is going to need to be able to do an interactive logon. Probably that use case of server admins needing to, for example, remote desktop and to administer like a web server or file server or whatnot. In those cases, there just might not be another alternative. And so in those cases, the best bet is really just to have them change their password frequently to avoid exposure. And so there are some password management tools out there which I would recommend you take a look at. One is from CyberArk, another is from Lieberman. And they're designed specifically for this issue of protecting or kind of managing your privileged accounts. And they work where you would actually log in to the system with a standard account. You would check out the privileged account for a short duration, then go do your work, and then when you finish, you check it back in, or it actually automatically checks back in after a certain time period. And once it's checked in, it's going to randomize, reset and randomize that password to a strong password. So at least that process, does a pretty decent job of minimizing your exposure over time. And going back to how I started on that, that's essentially what I was doing, by hand or in a manual way back when we first started with instant response. Is if I was concerned about it, I would reset the password. Of course, a lot of server admins aren't necessarily concerned, so you might need to be concerned for them and set up a tool like this that forces them to change their password. All right, so that was the interactive logons and why we need to avoid them. Let's move on to delegate level access tokens, and specifically kind of the topic of stealing delegate level access tokens. So what are access tokens? And basically, kind of like I did on the previous section, I'm going to start out with just this a real wordy slide, but I'm going to start out just kind of giving you some of the key points of the slide, and then I've got a number of diagrams here to help kind of hopefully bring home and paint the picture for you. So on a Windows system, every process must be run under the context of a user. So even for most, for most processes that, particularly those that start up at boot time, those are typically run under the process of a built-in user, like for example the system or local service or network service. But then for user processes, once a user gets logged in, they're run under the context of that locally logged on user. Now, a primary access token is actually provides all the information about that user and it is bound to that to that process. So that process, by virtue of its primary access token, knows what groups the user belongs to and what privileges the user has on the machine. And this is effectively what controls the rights and privileges of the process itself. It can't do what its parent user does. It can't do. So that's a primary access token. Every process has a primary access token. There's a second type of access token called an impersonation token, and that allows the process to take on the identity of another user for a short period of time. This is typically done in client-server scenarios where we actually have the server needs to impersonate that user, the client, for just a short time to do some work on that user's behalf. As you can see at the bottom, there's 4 levels of impersonation. The first 2 aren't really used that much and aren't too concerning from a security standpoint. The more powerful ones are the bottom 2, the impersonate level and the delegate level token. The impersonate level token allows the server to impersonate that connecting user only on that server system, only on that local system. The more powerful one, the one that we need to watch out for, is the delegate level impersonation token. And this allows the server to impersonate the connecting client on the local system, the server system, but also take those credentials and effectively authenticate and impersonate that user on another remote system. This is what is called the double hop. So we'll take a look at how this works. First, let's look at the primary token, and this one's pretty straightforward. So we have a standard user here. User's logged into his laptop. He launches Word. And Word is going to have a primary access token. And the primary access token is going to list the user's ID that launched it, as well as group information and privileges for that user. Now, this access token essentially puts some boundaries around Word and allows Word to determine, for example, this is a pretty straightforward one, but what files and folders, particularly files, that this user would have access to. So as the user essentially maybe tries to open up various files and folders, the primary access token and the information within it is compared against the access list on these files. And if the proper group membership matches those applied to the file, for example, then the user can, access that file. So essentially, it's this access token that kind of allows the process to determine what objects, in this case, what files and folders the user can access. Okay, so let's take a look at impersonation. Now, what if those files and folders are on a remote server? In this case, basically, it's almost the same idea, except that when Word connects to the remote server, it creates a network logon, and that creates an impersonation token for that server process. And for the server to check which files the user should have access to, it's basically looking up the security information within the impersonate level access token. Okay, so for that short period of time where that server is actually doing some work on behalf of the client, it's using that impersonate level access token of the user and is able to, again, like we saw before, able to compare the access list on the objects with the rights and membership of the user itself. All right, so let's kick it up a notch. Here's where we get into some interesting stuff with the double hop, with delegation level access token. So what I basically have here is a typical scenario where delegation is used. And if you're familiar with SharePoint, SharePoint's a great example of where we see delegation used very often. And that's because the typical architecture of SharePoint is a multi-tier architecture where you have a front-end web server and you have a back-end database server. The front-end web server is what gives us that kind of nice portal view and that we can browse through files and tasks and calendars and whatnot with our web browser, but actually all the data is stored on the back-end database server. Well, when our user needs to access that information, that back-end database server needs to know who we are and what rights and privileges we have. So what happens is this front-end web server in a multi-tier solution like SharePoint is actually trusted for delegation, and that's a key point, and I'll come back to that. But this server is trusted for delegation, and that means that when a user logs in, an impersonation token is created, but it's an impersonation token with the delegate level access, which allows that token to be used and essentially forwarded onto remote systems, which is exactly what we see here. Okay, so the user is connected to the web server. The web server then needs to connect as that user to the backend database server so that the backend database server can determine what files and folders and lists or whatever is back there on SharePoint that this user has access to. So here's where it gets interesting from an attacker perspective. We've got our leprechaun, and the leprechaun sees that, well, somehow he's gotten access to this server that's trusted for delegation, and perhaps he sees some tokens of users that he's interested in. Well, given admin rights on that server that has delegate level delegation capabilities, he can steal that delegate level access token and then use that to authenticate to remote systems. So I've got a screenshot here of a tool in action, Incognito. This tool has been around for quite some time, and basically it's a good not only proof of concept, but actually works quite well in the real world. It's actually built into Metasploit. I'm using the standalone version here, but effectively what I thought I'd do is just kind of go through an example of how this could work. So at the top, basically, well, let me give you a little bit of the scenario here too, is that, as I mentioned, basically an attacker is going to need to have some access to the system that's trusted for delegation. So in the previous slide, that was this web server. That web server is trusted for delegation and can host these delegate level access tokens. Okay, but let's do more of like kind of an IR scenario where essentially we've got an attacker that's basically gotten access to a host, and then maybe on that host, maybe the access they've gotten is with kind of a standard user account. So in this case, at the top, it's just standard user account Mike. But perhaps by virtue of this attack, this compromise, there was an alert that was sent off, and incident responders came to the rescue, logged onto this host to try to triage it. Well, if that occurs and this host is trusted for delegation, then the attacker's delegation token oh, sorry, not the attacker, but the responder's delegate level access token could be there and ripe for the picking for the attacker. So essentially the attacker can run incognito in this example, list available tokens, and if he sees the token for another user that looks interesting, then can essentially co-opt that and use it against other systems and authenticate to other systems. And here, that's exactly what I'm doing right in the middle, basically using some built-in commands from incognito that attempts to go through the available access tokens and use that access to add a user to a group. And in this case, because responder was actually had the rights of a domain admin, highly privileged, in this case, the attacker was able to use the responder's credentials, the responder's delegate level token, to connect to the domain controller, right there in the middle, dssecurity-scaper.com, that's the domain, and add user Mike, that's the compromised account that the attacker's stolen password hashes and maybe the password itself from. He's added Mike into domain admins. And he did all of that just with the delegate level token for responder. Now, I mentioned that responder logged in and basically did this, some initial analysis. The way I did this in the testing was it wasn't a login, an interactive login. It was actually with psexec minus, well, psexec minus u does create an interactive logon. It was with standard psexec, but I will say that this system was trusted for delegation. So I'll get into what that means here in just a minute. But at any rate, there is obviously can be some pretty significant impact for stealing a highly privileged delegate level token. In this case, the attacker was able to put their compromised account into the domain admins group. Towards the bottom, I just kind of showed you that this was a Windows 8.1 system, and it actually was run remotely against Seattle. Seattle was a Windows 8.1 system, and still token theft could be used on Windows 8.1. Also, I provided the timestamp there, which matches up with the event logs here from the domain controller. And I specifically just want to kind of show that, yes, this actually, the domain controller showed that responder up here at the top performed a login to the domain controller at this exact same time as the tool was run. And towards the bottom here, we see that responder added Mike to the domain admins group, all through the access, delegate level access token. Okay, so when do these tokens show up? I mentioned there are some things that kind of put some constraints around delegate level access tokens, which is good by default. So not every system in your environment, in fact, probably just a handful can actually even perform delegation. But when do they show up? Well, as far as if it's even possible, the system they're logging into is trusted for delegation, they're going to show up basically through either interactive logons or non-interactive logons if the system is trusted for delegation. So I'm really focusing in here on the bottom, and because that's the most important part. The delegate level access token is the one that can be stolen and used to communicate to a remote system. And as I mentioned there, we've got the use of encrypting file systems, kind of an interesting one where we have delegation in use, but also multi-tier solutions like SharePoint and others, either that are custom created by your environment or certainly there's other packages out there that use this kind of multi-tier solution that need that delegation capability. So last point there is requires either the service account of the user or the computer to be trusted for delegation. So for these delegate level tokens to be stored on the system, either the computer account, which is shown on the left, the properties of the computer account are shown on the left, or the service account that's running the service must be configured for delegation. So on the left is the delegation tab of a computer account, and on the right is that of a user account. They're basically identical. Both computers and users can perform delegation, be trusted for delegation. There's basically 4 options here. The very first option, which neither one of these are checked, the very first option is do not trust for delegation, and that is the default for all computers and users in the environment. So a computer or user account, typically a service account, would have to be trusted for delegation for it to kind of expose this capability. So after that, there's basically three capabilities. So the one that's there on Seattle on the left is trust this computer for delegation to any service. And then below it are, trust on a service-only basis. So either Kerberos only, and you can list out the services in that dialog box below, or any authentication protocol. So it could actually go beyond just Kerberos. On top of that, well, I guess actually I should say this is required for delegation to occur in your environment. And what I want to show, one of the reasons I actually wanted to show also that there are three options here basically that allow for trust, and that's kind of the three options at the bottom. Is what I found would be interesting is that since not every system in the environment or every user account in the environment is trusted for delegation, that would be interesting to build a query, and I put together here in a couple of slides coming up a PowerShell query that will go and look through all of your accounts, both computer and user accounts, and look for any accounts that have these settings enabled. So that way you can basically have, at least from a blue team perspective, some ability to kind of go deeper into monitoring for those kind of vulnerable systems. So to fix this, in other words, to protect against this for our privileged accounts, it turns out there's another setting that we can take advantage of on the users, and that's in the account tab. There's a setting here that says account is sensitive and cannot be delegated. For a long time, this has been a big best practice that Microsoft has had in some of their white papers and stuff, but it's usually kind of buried deep into the literature, so it's often hard to figure out what it is or why it's important. But it is quite important for kind of the reasons we just showed there in the example of using incognito and stealing that token. So for your privileged accounts, what you want to do is you want to set this checkbox. And what this means is that these sensitive accounts cannot perform the double hop. They cannot log into a SharePoint front-end web server and then after that log into a back-end SQL server. But I'm assuming, and at least I found this to be the case in my environment and probably most of your environments as well, that that's actually not all that important in most cases for a privileged account. So if you set this, you should be good to go. I have not seen it cause a problem with privileged accounts, but of course you would want to test to be sure. Okay, so that's the fix essentially for safeguarding these access tokens. For your privileged accounts, make sure that that setting is checked. Now, for your standard accounts, the people that, your regular account that you're logging in and checking email with and going to SharePoint with, you probably can't do that. But if your environment's not using these multi-tier solutions, then you could probably disable that as well. Okay, so what I mentioned is it'd be kind of nice to have a way to, particularly for big environments, to go through and just query all of your accounts and figure out if delegation's in use. Essentially, there are three options, and they're kind of listed along the top there. So allowed to delegate to, that's if you specify services. Trusted for delegation is it's just all the way trusted for delegation. And then trusted to auth for delegation. And I should probably point out that I'm basically saying these three columns here. Trusted to auth for delegation is essentially when you can use an alternate authentication protocol other than Kerberos. So if any of these are either true or populated with a service principal name, like in the case over here, then that means that that account is trusted for delegation. So at the top there, I've got basically a PowerShell command that runs it. It's kind of cool just to see it, in the console, but I thought what would be more useful is actually to be able to run it and pipe it out essentially to a CSV file. So here's how you can run it, and this is specifically against computers. So I'm using the get AD computer commandlet, and it's basically checking for any of those three settings, and if any of them are true or has a allowed to delegate to value, then it's going to output it into the CSV. And actually basically the exact same thing to run against users. So users have that same setup in their properties. So in this case, we can see service account did have the ability to delegate specifically to a SharePoint service principal name. And last but not least, as you're trying to kind of profile your system, see where delegation's in play, it turns out that if you have Windows 8 or 2012 in use on your servers or workstations, then it actually now is logging the impersonation level for connecting clients. So here you can see a network logon type 3, which, you know, that doesn't create the hashes and doesn't create the clear text password. But if that system's trusted for delegation, it could potentially create a delegate level access token, and that could be stolen and used for remote authentication. So that's what we want to watch out for. And for our sensitive privilege accounts, make sure that we've checked that little box that says account cannot be delegated. Okay, last but not least, and we're running a little short on time, so I'm probably going to whip through this a little bit. But what I'll actually say kind of first off is that I have an article, I actually have articles kind of on all of these topics on the SANS Forensics blog where you can kind of go deeper and get more links to them. And this is one of the topics I spent quite a bit of time kind of documenting too. And so I actually provide a link to it here in just a minute on one of the slides. But basically what's happened over time is that Microsoft has kind of progressed from a challenge response network authentication protocol. We talked about that earlier where you try to log into a server and the server sends you a challenge and you answer it directly with your password hash to a ticket-based system which is Kerberos. So the thing about this is, and the reason it's still actually interesting and useful to talk about the challenge response protocols is because, well, it's actually still in use in some cases. And Kerberos, it can't be used in all cases right now. So since it is still in use, let's talk about what really kind of the problem and what to be aware of with the challenge response protocols. And in this situation, really the problem is that we can kind of see from the diagram here, the server that you're connecting to is essentially man in the middle of the authentication exchange. Those on the top kind of the 3 steps at the top left of the diagram, that's the exchange we talked about a minute ago, where you request a logon, server sends a challenge, you answer the challenge with your NT hash. Well, right there, if that is a compromised host that you're logging into to do incident response, or you don't even know it because your tool's just basically scanning the whole environment, but it's compromised, well, you've already divulged some sensitive information. You've answered a challenge from that compromised server. And so this is a well-known algorithm to kind of calculate this, so the attacker can take that offline and try to figure out what password and password hash created that particular answer. Furthermore, it can actually be relayed. Now this is pretty interesting. So if you look at this, and I'll just kind of talk through this one, basically what happens is in step 1, just like before, we've got essentially the request to the compromised host. Well, the compromised host realizes I'd like to log into this other system, and maybe this highly privileged incident responder would like to log in, would have the rights to log into this other server. So before sending the challenge back to the client, this compromised host actually sends that same request logon to the server it wants to log into. Now, it waits for the challenge from the server, so the challenge sends the server back, and then the attacker takes that exact same challenge and sends it over to our unwitting and unknowing incident responder, for example. Well, the incident responder had issued a request to log on. The challenge eventually came, and now he's going to provide the answer based on his password hash. And that, since it's the exact same challenge that was sent from the unwitting and unknowing server over here, this actual client is actually, the server is actually able to send the same challenge back. So essentially, it's able to relay the answer onto to another system. Now, this has actually been implemented with tools for some time. There's SMB Relay and Metasploit that can do this. So it's something to be aware of. And again, in a best case scenario, the attacker is at least able to basically harvest the challenge and response. But in this case, it didn't even need to try to figure out what the password was that created that answer. It can actually log directly in to a remote system by forwarding or relaying those credentials. Okay, so Kerberos is actually here to help. There are some pretty significant problems with Kerberos. I don't mean to, and I don't want people to get the wrong idea that Kerberos is perfect. Actually, there's quite a few problems, and I'll point you to an article on that in a moment. But for this exact scenario, where we have a privileged account that we need to log into an untrusted host, well, with our privileged account, we're actually doing all of the authentication up here towards the top with the domain controller. And then we get a specific service ticket that's allowed only to that one host that we want to log into. And there's nothing really sensitive about your credentials, your privileged accounts credentials, that's going to that compromised host. So I'll mention real quick too that I did write an article about some of the problems with Kerberos, and there's a lot of them. So I've got a link to this at the end of the presentation. But what I want to make sure you understand is that the way we've talked about this, where we're using a privileged account to reach out to compromised hosts, this is still completely valid, and your credentials are safe. The problem comes in, and I spent quite a bit of time on putting together a diagram of this. The problem is if the actual compromised host is the one requesting the authentication with a domain controller. Then we get into a number of issues that you can see here. Okay, so I'll leave that to you for some reading later, and I'll point you to how to get to that article here in just a moment. So the long and short of it is that Kerberos for our use case is actually very valid in what you want to use whenever possible, but unfortunately there are times when you can't use NTLM. And really the very probably thing that's most likely to be an issue here is this guy right here. So when you're authenticating over an IP address, or you're authenticating to an IP address, Microsoft is going to fail back to NTLM. And it's doing that because it can't resolve the host name, and the host name is actually embedded in that service ticket that it hands off. Okay, so what we can do though is we can actually lock our systems down. So this is on your trusted host, and you want us to configure your trusted host to only allow Kerberos and not allow NTLM. So that's basically what we're doing right here. We're going to deny all for NTLM, although in the local security policy you can actually even provide an exception if you need to. So in this case we accepted 192.168.6.12. So this is one way, this is with Windows 7 and higher, that you can lock down and enforce Kerberos and basically restrict outgoing NTLM. There are event logs here that actually provide information to help you troubleshoot and determine that a particular request was blocked because NTLM is not allowed. And so the takeaway is enforce Kerberos whenever possible. As I mentioned, there are times when you're going to have to do NTLM. So you want to also have your security policy set up to accept only the highest level of NTLM, which is version 2. And you also want to use very strong passwords because even NTLM version 2, that attacker could be man in the middle and basically see the challenge and answer and take that offline to try to crack it. There's a lot of information here about a technique called extended protection for authentication, which is actually probably the most robust way to improve the security of NTLM, and that's where you basically embed the host name into and sign it into the request so that it can't be relayed and forwarded. So there's more details in that link, and you can definitely read up on that. All right, so just a couple slides left. Basically, what I want to say is, regardless of your environment, legacy environment or brand new, it really boils down to 3 things that you need to do when you're connecting out to untrusted hosts. You got to avoid the interactive logon, so just network logon type 3. Protect that delegate level access token by setting the account as sensitive and cannot be delegated on your privileged accounts, and enforce Kerberos network authentication. So you can do that basically on any system, Windows 7 or higher. You can do all of these things. In fact, you can really do all of this except enforcing Kerberos network authentication even back on XP in 2003. Now, I mentioned a little bit about this article, and actually this update, this KB that came out back in May of 2014. It actually brought a number of things up to the level of Windows 8.1 in 2012. Really, just point out a couple of things. One is this protected users group. By default, if users are added to the protected user group, they're going to take care of two of those three things we just mentioned. They're not going to be allowed to use NTLM. Oops, that's not the one I wanted. They're not going to be able to use NTLM, and they are not going to be able to delegate their tokens. All right, so you're taking care of two of the three just by putting members in protected users. On top of that, it does have some ability to use what's called restricted mode RDP, but that's actually still going to, and essentially what that does is give you a desktop access, desktop level access with remote desktop, but it's still just a network logon, which is pretty cool. So for those cases like the server admins that actually have to have a desktop, restricted mode admin and restricted mode RDP specifically is very nice. So they can log in with that, get that virtual desktop, but not have the credentials exposed. Downside to that is even with the patches, the system that they're connecting to must be 2012 R2 or Windows 8.1. So so it must be one of these guys, you know, for this to work. So just a few final points, things to look out for. Essentially, you know, you always want to be aware of suspicious activity for your privileged accounts, have higher level auditing and alerting on those accounts. Look for unusual logons and logoffs for strange times or strange locations. And helping me with that is something that I've been interested in, is trying to continually improve the audit policy on your Windows domain and in your workstations. I highly recommend this Microsoft Best Practices for Securing Active Directory. That's a white paper that was released a couple years ago, but if your environment's anything like mine, you have to have Microsoft's backing to make any significant changes. So having Microsoft basically lay out real specific and actually pretty strong auditing or logging policy in this paper, which they did, is really helpful. Also, something that we found useful in our environment too is process tracking, where it's going to put in an event for every single process that's run on the system. That might sound overwhelming, but we've actually not found it to be a problem. And just last month, this KB article 343.75, it actually added not only the ability to log the process, but what command line parameters were issued with it. So when we go use, say, the net command, we can see that it's going to net use whack whack, you know, domain controller, server admin, or whatever. And finally, assign, you know, basically try not to have these global groups like, you know, a massive domain admin group where everybody's lumped into. Try to, you know, delegate on smaller groups that maybe have access to a particular region or particular type of system. And as I mentioned earlier, things like the password management solutions like CyberArk and Lieberman are helpful. Okay, so I went a little over my time. I thought I'd have a little extra time, but what we have here are some links to find out more information. The best thing to do, like I said, I've spent quite a bit of time researching this and writing about it. If you just go to the SANS Forensics site there and search my name, you'll find all the articles I've written on this topic. There's the Microsoft Best Practices Guide for Securing Active Directory, some other good sites and white papers and tools that I've found for this type of researching this material. Okay, so of course the slides are going to be available for download. Also, this is my contact information. Feel free to email me if you have any questions. I'd be happy to answer them. And at this point, Trevor, I apologize, thought we'd get finished a little earlier, but I'll turn it back over to you. And I'm not sure if we have time for questions or not.
No problem. It looks like we are out of time. If you have any questions, feel free to email them to q@sans.org or the speaker. We'll be happy to make sure those get taken care of. I would like to say thank you so much to our featured speaker, Mike, for his great presentation and for bringing this content to the SANS community. To our audience, we greatly appreciate you listening in today. For a schedule of all upcoming and archived webcasts, visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.